Hello everyone, it has been a while, but I am back with another Unity tutorial. This one is going to cover the NavMesh or navigation mesh feature of Unity, which has been around since pretty much day one and has gone through some iteration and some changes, and nothing bigger than what's occurred pretty much just recently after this, after I made this video, which is the experimental component-based NavMesh feature is now looks to be not experimental anymore. It looks like it's more natively supported now. So that means that it seems like Unity is encouraging people to start using the new component-based system rather than the legacy single NavMesh surface baking version of that system. So to help alleviate some confusion, I am going to go through the component-based system and explain what each component does and demonstrate how this might be used in a game with my very, very rudimentary examples, but hopefully it will get the message through. So let's go. So the NavMesh feature, it's been around, like I said, since pretty much the beginning of Unity. What used to be what they considered a pro feature of Unity, there was a pro version of Unity that allowed you to do certain things that were not available to people who didn't essentially pay for the software. They've changed that around a little bit, as you know. Now there's a free version of Unity for everyone to use with some other pro features that are more enterprise related and for larger projects and things like that. But the good news is the NavMesh system, including the component-based one, is included in the free basic Unity package, and it is a much better way to do the NavMesh pathfinding, as you'll see. And I wanted to demonstrate how these components work together and what you can do with them. So let's go. The NavMesh system is good for many things. It has limitations. It's not perfect. You will probably find things that it doesn't do that you would prefer that it did, but for many purposes, it can be a very good way of moving an agent or a character or something around an environment and have it avoid obstacles, go over terrain, different types, traverse things from one area to another, and the general stuff that most people would like to do with a character-based game. It's pretty efficient and doesn't take up a huge amount of CPU, especially if you use it correctly. And I will demonstrate how some of the new real-time baking features or real-time building features work. So the old system was good for static things that didn't move around in your scene, in your game, static geometry, terrain, things like that. But if anything was moving, then you had difficulties. They would have to become something called obstacles, and that was kind of limiting and didn't allow you to actually create nav meshes that included the obstacles. And some of those things have been updated now, and you have much more flexibility. So I'm going to demonstrate how this might be used, and you will see if this is something that will benefit your games. And before we get too far along here, I just wanted to point out that unless you are using Unity version 2022.2, you might have to double check your package manager to make sure that you have the AI navigation package installed. And I will put a link to the previous way of doing it in the description, but as of 2022.2, you should be able to find it in the Unity Registry under AI navigation, and the version that I'm using as of the making of this video is 1.1.1. All right, so let's come over here to Unity, and we'll get started with what we're going to do to build our NavMesh example here. So I have an empty scene, just have our camera and our light. I'm going to come over here and edit my layers. The layers are going to come in to play soon, and this is an important part of the process. So we're going to add a layer. We're going to demonstrate something like a road and a sidewalk and maybe like an interior space. So we're going to create a layer for road. We'll create a layer for sidewalk and maybe one for inside. And one more I'm going to create is called shared, and you'll see how that works later. And one more actually that I want to add is called modifier. Again, I will explain what this one is going to do soon. Okay, now next thing I'm going to do is I'm going to go up here to window, And under AI, if you're using Unity 2022.2, which I am, this is brand new for this version, you'll now see there's 2 items here, actually 3, and when there used to be only 1. And the old navigation UI panel here has 4 tabs: agents, areas, bake, and object. And with the new component system, these last 2 aren't used. So we're going to close this one, and I'll show you that we're going to be using this new navigation tab. It's the same thing basically, but it has only these 2 tabs, agents and areas. So let's dock this guy over here. I can do that. And next thing we're going to do is we're going to create 2 agent types. And I've already created my agent types here. One's called vehicle, one's called NPC. Let's just say that's for a character. Okay, so we're going to, for the NPC, I'm going to set my radius to 1, my height to 6, and these other settings here are not critical for this example, so I'm just going to kind of pick some settings that work okay, and that's my NPC setup. And then if you don't already have another agent type here, you can click this plus sign and add a new one, and this one is going to be called vehicle. The radius is a little bigger, the height is a little smaller, and then some of the same settings here. So the important thing is that you have 2 different agents, and an agent is going to be used for each of the types of characters or the objects that might be moving around in your game that you're going to be using pathfinding for. Okay, so we're going to now go over here to areas, and we're going to add just a couple new areas. One of them is going to be called road, and the other one we'll call inside. Now, if you're familiar with pathfinding in Unity, you'll be familiar with these already. They become more flexible with the new system, so I'm going to show you how that works. Now, notice I put the navigation tab in a separate panel here as opposed to like this, so that we don't have to keep clicking back and forth, because when this is active, you will see your navigation mesh in the scene view here, and that's important so that we can visualize everything we'd like to visualize. All right, let's get started. We are going to start from scratch, and first thing I'm going to do is I'm going to create an empty object. Now, depending on what your settings are, make sure that your empty might be created somewhere other than the origin. Let's just make sure everything is nice and clean, put it at the origin. So we're going to right click here and say reset, and reset our empty to be at the origin. We're going to call this NavMesh Root. And I'm going to demonstrate a workflow that works really well for what I've been trying to do. It's not super well documented, and it isn't something that I think is explained anywhere, and I haven't seen anybody else kind of talk about it in this way, but this has been working really well for me. So let's go ahead and continue on. Okay, so now we have our NavMesh root, and we're going to add our first component, and we're going to add, I have typed in here NavMesh surface, looking for NavMesh surface. I'm going to add that component, and you'll notice that it has some of the same agent information, but its radius. We want to make sure our agent type is set to NPC. That's the one that we had created earlier, and that means that the surface is going to be targeted at a NPC character as opposed to, let's say, a vehicle, which is the other thing we have in our game. These are very arbitrary, but this is what I've called them. We want the default area, which is, if you recall, under here, areas, we want the default one of these to be road. Even though this is an NPC, we're just going to have him be on the road. Now, the important part is under object collection. This is where we want to take advantage of what we're allowed to do here. So rather than say all game objects, which we don't want, we want only the current object hierarchy. So some of this has changed since the last iteration of the new component-based pathfinding AI. So if this is looking a little new to you, that's the reason why. Make sure you're on version 2022.2. And then where it says include layers, we only want to include the road. So we're going to say nothing, and then we're going to turn on road. So now any object that's in the road layer will be included in this NavMesh surface and nothing else. All right, and just to take a quick look at what this script does. So in the awake function, we're just going to collect all of the NavMesh surfaces in the scene. And in the update function, for every NavMesh that has some NavMesh data associated with it already, we're just going to update that data. Otherwise, we're just going to build that data for the first time. And this isn't something that you would do normally in your game, but for my demonstration purposes, it just helps us keep track of all of the NavMeshes and what they look like in real time. All right, let's keep going. So now we're going to add a child object here, and we're going to just use a plane. Going to scale it up a bit, 10 by 10. All right, and this is going to be like, we'll just consider this as our road surface. So we're going to set the layer here to road. Okay. And now we're going to add an empty object. Oops, we want that up here. We'll call this our agent. We'll reset the transform, make sure we're in the middle here. And we're going to add a NavMesh agent. So this component hasn't really changed since the previous versions. And this is the component that controls any sort of AI character that's going to be pathfinding on a surface. We'll make sure the agent type is set to NPC. And we will make sure that the auto repath and the auto traverse is set, which is set by default. And then the important thing here is area mask. Now what this does is it basically says what areas is this agent allowed to be on as far as the NavMesh is concerned. And so right now it's any area this agent is allowed to be on. And we're going to change that. We're going to turn it to nothing, and then we're going to say we want it to be on both road and walkable. So that means this agent is allowed to be on the road, and it's allowed to be on anything that's considered walkable. All right, and so now to make things a little bit easier to visualize, we're going to create another empty object. We're going to call this target. And this is just going to give us a transform, again, make sure you reset, that can be moved around and make it it's for us to visualize where the agent might be going to, a target for the agent to walk to or move to. We're going to move this from where it is right now. We're just going to kind of put it over here in the corner. Now I have another custom script here that is basically just something that allows me to just show and demonstrate things that the agent is doing and to test things out. And I called it NavMesh NPC test. And I'm not even going to really show what this code is because it's basic stuff, but basically this allows me to control the agent and have the agent draw the path that it's going to and move it around. But we do need to make sure that this property is set to the target so that it knows where to go. Okay, we're ready to press play and have this thing go. So let's do that. And the first thing you're going to notice, oops, of course, we don't need that. The first thing you're going to notice is we have this purplish colored rectangle being drawn, and that's because of the navigation tab doing our visualization for us. This wouldn't normally be shown, but it is helping us out here for quite a few things. So first thing is you can see there's a darker colored square here, and that represents the zone or the area of the NavMesh that the agent is currently occupying. And it's lit up or selected or whatever you want to call it, such that this agent is a member of this zone. And as soon as I move the agent around, you can see it changes the zone. Okay, let's explain some of the other things going on here. So what did I just do? I clicked on the agent and I selected this. If you haven't done this already with the gizmos in Unity, you kind of know these squares are good for moving things along two different axes at the same time. And so this green one is the XZ plane, which is really great. And so I can move this around on XZ plane without having it going up at all. You can see over here only X and Z are moving. So if you didn't already know that, it's a nice little handy tip for you. So the agent is locked to this mesh, this nav mesh, which means that it can't go outside of it right now. If you tried to move the agent outside of this nav mesh, it wouldn't work. It is currently locked to this nav mesh. And how did that happen? Well, this nav mesh agent was set to, the area mask was set to walkable and road. And we built, if you remember, we built a nav mesh in real time by attaching the script using these parameters. And so we are building a nav mesh in real time whenever I press play that is set to the default area of road, and it is all the child objects of this nav mesh root, and of course there's only one, and it's the plane. So the plane object is essentially the entire nav mesh. It's a single object, and it's all of its surface area is considered road. So another thing to consider here is when this agent moves around, the red line here represents the path that the agent is going to follow when it has calculated how to get from where it is to its target destination point. If you remember, the target is the point the agent was told to go to. And so this is the path that the system has calculated for this agent to get to that target. When I move the target around, you can see the path is updated. You can also see the path is constrained to only within that purple road nav mesh region, which is kind of what you would expect. All right, let's keep going. And now what we're going to do is we're going to right click on our NavMesh root object. We're going to add another 3D object, another plane, and we're going to call this one sidewalk. So we have our road here, and then we have a sidewalk plane that we've added. It's going to pretend like it's a different surface type or area type. Make sure the transform is reset. We're going to set our Y value to just a tiny bit up so that it doesn't overlap completely with our road plane here. And let's just call this road so we don't get too confused. Okay, and we're going to move this guy over here, and I'll show you something that maybe not everybody's using, another little tip along the way. If you press the T key on your keyboard, or you go over here to this tool here, you can actually more easily transform rectangles so that I can kind of drag either end of it, which is a lot easier than trying to figure out how to scale it to those dimensions. So really handy. I really like using that one. So we've got a little thin strip. I'm going to make it a little bit wider, and that is going to be what we think of as our sidewalk for this demonstration. And we're going to have it overlap the road just a little bit. And then the last thing we need to do is make sure we set the layer to sidewalk. So that indicates that that's a different area that we want to use. Okay, here's another piece of information which might be useful and not as intuitive or well documented. You can have multiple NavMesh surfaces within an object. So we have one already for the agent type NPC for the default area road, but what I'm going to do is I'm going to add another one. Now we have a second one, also going to use NPC, but this time the default area, which is already set, is going to be walkable. So I had one that was NPC but road, and now I have NPC and walkable. And again, in object collection, we're going to make sure this is only the current object hierarchy, which means it's only going to be this and everything below it, which is exactly what we want. And then again, importantly, is we're going to set the layers that are included to only the sidewalk. So again, the included layers for each of these NavMesh surface types, or NavMesh components, I should say, are the only thing that's going to be processed by the NavMesh surface. The NavMesh surface will only include items, objects that are in these layers and nothing else. Okay, we're going to press play again. And now you'll notice we've got two different colors. Okay, what are the colors? Well, remember the road was an area and the walkable is an area. So the color is this color here. So it's user 3, it's kind of a purplish color, that's why this is purple. And our walkable area is kind of a light blue, and that's why this one is light blue. And then this color is darker here because these two areas are overlapping. And that's important for what's going to be shown later. So let's close that up a little bit. Now, you'll notice that our agent was set with the area mask of walkable and road. So that means our agent can go on either any surface that is considered a walkable surface or a road surface. So you might think, okay, well that means that this agent ought to be able to go on both these surfaces at once. Not quite. And let me explain what I mean. Okay, so an agent that is tagged with walkable or road for its area mask, yes, it can go on any surface that is considered walkable or road, but that doesn't mean it can go on both road and walkable at the exact same time. Now this agent right now is locked to the road type navigation area, road, only road. If I were to stop here and move the agent over to the edge of the sidewalk over here and press play again, you'll notice now the agent is locked to the sidewalk area, which overlaps our road as well, as you can see. So the agent can go on either surface, but once it starts on a surface, it can't leave that surface. The only way it can leave the surface is using what's called an off-mesh link, or if you were to disable the agent and move it around normally like any other game object and then re-enable it, which would then have it look to see if it can find the closest NavMesh to lock to again, then that's the only other way you could do it. If we're looking for a way to have this agent be able to go on a sidewalk surface and a road surface simultaneously so that I can drag it all the way across and over on both surface types, that's where we use the shared surface type concept, which I will demonstrate a little bit later. For now, agents can only go on the surface types that they are locked to when they are first enabled, and cannot get off of these surface types without using off-mesh links. All right, so now it's time to talk about the concept of a shared surface type, which this is my terminology, but it's practically speaking, that's what we're doing. And what that will do is allow us to create a surface type that an agent can go on simultaneously, seamlessly, as if they were all one type of surface, which it really is. It's called shared. And I'm going to demonstrate what that's all about. Now, in the meantime, here I have enabled some or added materials to these surfaces, or to these planes, to make them a little bit more obvious that they're overlapping and just easier to kind of see everything going on. They're just using a semi-transparent material to make it easier to see them. All right, so I'm going to take this sidewalk plane, I'm going to duplicate it, and I'm going to call it driveway. The driveway is the kind of like the way to get from the road to your house, to your maybe to your garage, and in general that's a surface that people walk on as well as drive on. So that's why I'm going to use it as the kind of the way of demonstrating what a shared surface is. So I'm going to kind of zoom out a little bit. I'm going to take this driveway object, I'm going to move it up here, I'm going to rotate it a little bit, kind of move it this way. Let's do that. And whoop, let's have it kind of overlapping with the other two surfaces. And actually, I'm going to kind of scale it a little bit as well. Okay, I'm going to set the layer of this to shared. So that's where that shared layer is coming in. Now we're going to have the agent, and we're going to put the agent back on the road. We'll go over here to the NavMesh root, and we're going to add the shared layer to the include layers here. So again, these are, you can have more than one. And so we're going to include shared here, and we'll go to the other one, and it's going to be shared here. So now what this means is when we generate the NavMesh surface, we're going to be collecting objects that are not only in the road or sidewalk layer for each of these respectively, we're also going to allow both of them to collect objects that are in the shared layer. So that means that the NavMesh surface that tags something as either road or walkable, both the shared objects in the shared layer are going to end up in both NavMeshes. And that's exactly what we want. So there's going to be a little bit of duplication there, but that's actually what we want. All right, so we're going to click play. And you'll see that the driveway surface is now a different color. It's actually this kind of like purplish color. And that's because there's actually two NavMesh surfaces here. If I turn one off, you can see there's one, and if I turn the other one off, you can see there's the other. So it's kind of combining the colors, but it's really the combination of this color and this color is this color. So this NavMesh surface is essentially in either one of these surface types. So anything that's marked in the shared layer will actually be combined together into one common NavMesh surface, which is something that might be quite powerful. All right, so now you can see our agent, which is locked to the road. Oh, you'll see that it's also able to now seamlessly go from road to this shared surface. So this is all part of the road and shared surface together. So there's no need to use a link or any kind of disabling or enabling of the agent. The agent can seamlessly go from road to driveway in this case. If we were to stop and move the agent over to the sidewalk, let's make sure he's completely on the sidewalk. Start it again. Now again, you think he's locked to the sidewalk. That's true. But because there's a piece of the sidewalk that overlaps with this shared driveway surface, the agent can seamlessly move from the sidewalk to the shared surface as well, which is also very handy. And if you notice, this little red path gets updated as I'm doing this. And so agent can go anywhere these two surfaces are connected to each other. Let's move the agent back to the road. Press play again. And again, notice that the target can be either on the road or over here in this shared area. Now, if I were to move this sidewalk area, let's say it's not touching anything, and I click play, and so our agent right now is over here. Let's move it onto the sidewalk. Now, you would expect that the agent can only move within the sidewalk area. And that's, even though this is considered shared, it's not touching, it's not adjacent enough. If I can actually move this sidewalk in real time, and you'll see it update. I'm going to zoom in really close over here so you can see what happens. But I'm going to move this object, and now you can see it connects up. See that right there? Right over here, you can see it's connecting. So it's disconnected here, and now it's connected. And if you'll notice, if I move my target to inside the shared area, so there's a red path being calculated for the agent, which is over here. And because the sidewalk is connected, the agent can make its way all the way to the target. As soon as I move the sidewalk a little bit out of the way, notice now that path ends at the end of the sidewalk. It can no longer get over here because these two areas are not connected anymore. Now, if I wanted to get the agent from here to here, even though they're not connected, because let's just assume that these two surfaces aren't connected and can't be connected, that's where links come in, and I'll show that in the next section. All right, now let's talk about modifiers. Now, a modifier is an area, either with geometry or with some kind of volume, that is designated as a different area type. So again, area type, meaning the type of area that is shown here in the navigation areas. And so it's limited to whatever's here. But modifiers basically can take an existing area type and take a portion of it and designate that portion as being of a different type. So what I've done here is I've kind of pre-created a scene with the same kind of stuff as before. But now we have our road area, which is unchanged. But now the sidewalk and another area now called inside, which both of these now have a NavMesh modifier. And so a NavMesh modifier is just a component that you can add to any geometry, any object. This area is designated as a different area type. So we are overriding what was already there, which is in this case road, and we're making it something else instead. So modifiers can be a powerful way to adjust the surface types in the cases where you don't want to have to create all different geometry all the way around this area. Let's say I have here in the middle. Instead of having to create all this geometry around it, I can just put something right on top of it, and it replaces everything underneath it with a different area type. So given that we have our road here, we have our modifier here for sidewalk here, which modifies everything under it to the walkable area type, and this one does the same thing for the inside area type when we click play. So now you can see the agent is allowed to walk on the walkable surface as well as the road surface, because these surfaces are both connected to each other because they were collected by the NavMesh surface because it was told to do that. And the reason why is each NavMesh surface was given not only to include its default layer, in this case the one that generates the walkable surface type here, got it from both the side objects and the sidewalk layer, but also in this new layer that I had called modifier. If you notice, if you remember, I created a layer for modifier. So the trick here is that the NavMesh surface includes the modifier layer as well. And so this object, this sidewalk object, is in the modifier layer, and so is this object, this inside layer. So because they're both in a layer that's collected by the NavMesh surface, in both cases, any geometry that overlaps, that it's in the same collected layer or same group of collected layers, will be merged together into one seamless NavMesh. And so this agent is able to go on all surfaces that are marked with road and any modifiers as well that the agent is allowed to walk on. So remember, the modifier is telling the NavMesh that this area should be designated as different than road. It's designated as walkable. And because the agent can go on both walkable and road surfaces, it can go on both of these seamlessly. Whereas the inside surface type, the agent is not allowed to go on that surface type because it's not one of the ones here in area mask, and so it is not able to go on the inside layers here. And again, because I'm doing everything in real time, I can also kind of show you what happens when you move things around. There's a little bit of a delay as I move these objects, as it rebuilds the NavMesh sort of asynchronously. But you can see as I move it around, this modifier is modifying anything underneath it. Same with this one here. It's going to modify anything underneath it, and will merge surface types when it can. So this is a great way of kind of seeing how it's building NavMeshes in real time. And the last thing I'll mention here is that as long as all NavMesh surface components include the modifier is one of the layers. Anything that's considered a modifier on the modifier layer will be included in all NavMesh surfaces, if that's the way that you would like to do it. And that can be a pretty powerful tool. All right, now let's talk about NavMesh Obstacles. So as opposed to a NavMesh modifier, which modifies the NavMesh surface type or area type, an obstacle is an area that the agent is not allowed to travel on, but it can move around. And so generally modifiers are not expected to be moving around, but NavMesh obstacles can potentially move around. And they also prevent the agent from pathfinding through them, as you'll see in a minute. So I've got a new scene here. Same kind of setup. I've got my two NavMesh surfaces for both walkable and road. And there's the road surface. Now I've introduced this new thing called an obstacle. Now the obstacle doesn't have any geometry. There's no actual model here. It's just a cube. And just to demonstrate that obstacles don't have to be physical things. They can just be kind of invisible things as well. Same setup as before. I have an agent and I have an agent target. Now watch what happens. Here's the agent. He's right in the middle of this road. But the obstacle, as you'll see, is right on top of the agent. So when I click play here, watch the agent. It just jumps out of the obstacle. It's not allowed to exist in this obstacle based on the fact that the obstacle is in the way of the agent. It's a area that the agent is not allowed to go. And so just like any other area the agent's not allowed to go, you can see that the NavMesh is kind of created around the obstacle. Now the interesting thing about obstacles is obviously we can adjust their dimensions in real time if we want. I can make it smaller, bigger, narrower, and you can see this. Notice the red path that the agent is going to be taking. It's recalculating at every frame, and as I move the obstacle and make it bigger, the agent is pathing around it further and further because it's not allowed to go through it. And if I move the target around, you can see it's sort of trying to figure out the best way to get from this target, from the agent to this target. And it's pathfinding around this obstacle. Now the obstacle has several options, which can be interesting and affect how you might design your levels. This carve option means that the obstacle actually carves out a space in the NavMesh. You can see this empty area here is not part of the NavMesh. If I turn off carve, then the agent the obstacle still exists, but the agent cannot go through the obstacle. So you can see it's kind of stuck. It's not going around it. It's not allowed to go through that obstacle. But if you notice, it can still pathfind through it, which is the interesting aspect. So when we turn the carve on, it's no longer able to even pathfind through the obstacle. So those are the differences between carve and not carve. And the other difference is that if this obstacle is moving, you have an option to carve if the object is moving or not. So if we use the carve only stationary option, that means that if this obstacle is moving around, it's not actually affecting the NavMesh. It's not carving the NavMesh as it's moving. It will only do that once it stops. And that's what this time to stationary value indicates, is how long it takes before this object is considered stopped moving. So if I increase this to let's say that about 6 seconds, so as I'm moving it around, it will wait 6 seconds before it actually carves out the NavMesh. So here we are waiting for that. And finally, after 6 seconds, you will see that it has now carved the NavMesh. So it's kind of an advanced feature, but it might be something that is frequently used depending on how your game is designed. And the move threshold is a similar thing. It just means that how much distance does this thing need to move before it's considered no longer stationary. And so if it's set to a small amount, and this is set back to a small amount as well, then you'll see that even a small movement considers that it has moved. But if I increase this to a further distance, it needs me to move it a certain distance before it starts to recalculate. As you can see, I can move it around a small amount, and it won't carve unless it's moved a certain distance away. If we turn this off, then it's carving constantly. And again, the difference is a carved nav mesh means that the path goes around the carved area, and one that isn't carved means the path can go right through it. But this obstacle is still an obstacle no matter what. As you can see, it's kind of pushing my agent around as I'm moving. So the agent cannot exist inside this obstacle. All right, so here we are at our final topic, and this is by no means the only remaining thing to talk about, but it will be the last thing that I will share for this video. Please indicate anything else you'd like me to cover. If there's something that's confusing, please let me know. All right, so the final topic we're going to cover today is the topic of links. And a link, it used to be called, I think, off-mesh link, maybe it's still called that. Basically what this is a way to connect NavMesh surfaces that are distinct, that are not the same, and regardless of their area type. So any area type of NavMesh surface can connect to any other NavMesh surface of any other area type as long as there's a link between them. And you can add a link by adding the NavMesh link component to basically any empty object you want, or any object you want, really. I've added it to a couple of empty objects, and we're not going to worry too much about the parameters here, especially this one called width, which I have found does not actually work at all. I might be wrong in that, or maybe it was a bug when I was using it, but if you set it to anything other than 0, something seems to not work with it. So given that, we'll just kind of ignore it for now. The two that are most important here are the agent type, which is the agent that's allowed to use the link, and the area type, which is basically what area type is the link itself. And that is used for costing purposes, and maybe some other logic in your game might take advantage of that area type as well. And of course, you can use the area type to allow or disallow one of your agents from crossing that link. And so if it's some kind of special bridge or something that requires a certain area type of movement and your agent doesn't have that area type, it can't traverse that bridge. It doesn't affect whether it can go from one area to another. It's only the link itself. What kind of area does that represent? So we are going to take a look at this example. So I have an agent who's over here, and the agent is currently using the walkable area mask. So the agent can go on anything that's considered walkable. And so this agent is locked to this sidewalk area that's a walkable surface. And the game would like the agent to be able to go to this road surface. Now right now the agent can't walk on road, so that's not going to work. If we set the target is set over here to this road, and clearly the agent would have to traverse this link and this link in order to get to this area here. And these links and these surfaces are all considered road. And so this agent can't get there. So that's why you're not seeing any pathing available here. But when I change the agent's walkable area mask now to road, this path now is generated. So this agent could theoretically go from where they are right now all the way to this target right here. Now in the state I can kind of move things around, and as long as the surfaces are connected, the agent will be able to get to the target position. So as I'm moving things around, you can see I've lengthened the link. The link is connecting these two surface types. The agent can still get there. One important thing to note, which has always been the case, is agents will not traverse these links just by moving them with the move API or the move function. You have to call set destination. And so that basically automates the agent's traversal across the links and to the ultimate destination. However, as I've said earlier, the path itself is useful. If you're planning to move the agent on your own, you can take advantage of the fact that the pathfinding system has created a path for you, and if you choose to move the agent yourself, you can have it follow this path. You can ask, the API will give you all the points on the path, and you can move your agent as you see fit according to that path. So sometimes just the path is good enough. And then, of course, links can be bidirectional, which they are by default, or if you turn that off, they can only go in one direction, and that would be from the start to the end. And that's if you want a one-way traversal, but not have it be able to go back the other way. There's all kinds of possibilities you can do with these links, and it depends on the type of game that you're making. And in this example, I've just reversed where the agent and the target are. And again, you can see because these links are bidirectional, the agent is allowed to go in the other direction across these links. And then we can just play around with where the target is, and you can see the path is calculated across the link each time. When you get to another NavMesh surface where there's a link connecting it, you can see that it automatically generates a path across that link. And just one other thing to note here, that when I move the agent in this way, this is equivalent to calling the agent's move function. I'm just doing it in the editor. You'll notice you can't move the agent manually across this link. I can't go across any of these links with this agent. That is not something that is possible to do with just moving the agent. The agent will only traverse these links automatically if you use the agent set destination function. So agent can't go across this manually. What you'll have to do is you have to disable the agent, which detaches it from the NavMesh. You can then move it just by moving its transform. So essentially what you're doing is you're going to disable the NavMesh agent by doing that in the code. You can then move it across the link and then re-enable the agent on the other side, and now you're allowed to go over here. And just to demonstrate, if I were to tell the agent to traverse to this destination here, you can see it traversing across the links, and from one surface to the next, it'll follow this red path as you would expect, and it will end up at its destination. All right, well, I hope this video was informative for you and helped explain NavMesh components a little bit better. Please like and subscribe, and if you have any comments or anything you'd like me to cover that I didn't in this video or in other videos, please make some suggestions in the comments, and I will see you in the next one.